What is up, Algebros? This is lesson 12.4, and today we're talking about finding the sum of an infinite geometric series. We've already talked about finding the sum of a partial sum of a geometric series, where we're not trying to find all of them, but just the sum of a certain number. But now we're talking about finding an infinite, which is kind of a crazy idea, where we're adding up an infinite amount of things, but somehow it's adding up to a particular number. Just to kind of wrap your mind around that basic concept here a little bit, we're going to look at a square with each side dimension of 1, say 1 inch or whatever you want. Well, if I were to cut this square in half, this area here on the left would represent 1/2. Okay? Well, then if I cut what's left over in half, this here represents the area of 1/4. Well, if I cut what area is left over in half, this area here represents area of 1/8. What's left over here? Cut it in half, it's area of 1/6. If I keep going, cut this in half, the area here is represented by 1/32. And you can kind of see, as I keep adding these up, it's going to come closer and closer to filling in this whole square. Now, once the whole square is completely filled in, there's no little half part that's missing there, all of those would add up to, well, the area of the square. 1 times 1, which is 1. So if I summed up an infinite number of these, it would sum to fill this completely. Now, if I stopped at any point, and if I just did the first 200 of them, it wouldn't quite be 1. I'd still be missing a little bitty piece there in the middle. However, if I summed up infinite of them, it would actually come and fill in this square completely, meaning the infinite sum would be 1. So remember from 12.3, we had this partial sum for geometric series. Okay. Oh, and notice this is a geometric series where the first term is 1/2, and the common ratio is 1/2. So multiply each one of these by 1/2. So notice this was the partial sum, okay? But think about this r. If my r, the absolute value of r is less than 1, meaning it's a number between -1 and 1, or that common ratio is like a fraction, like 0.5 or 3/4. If that number is between 0 and 1, then that means as r to the n will approach 0 as n gets really big. What does that mean? Think about, say, 1/2 to the n. Well, if n is just 1, then this would just equal to 1/2. If this is 2, it'd be 1/4. If it was 3, it'd be 1/8. If it was 4, it'd be 1/16. So notice as n gets bigger and bigger and bigger, this number is going to get smaller and smaller and smaller and smaller and smaller and smaller and smaller. In fact, it's going to be, in mathematical term, we say it approaches 0 as n gets really big. Okay? So if this thing right here is approaching 0, then this sum right here is really going to be the same thing as this, as it gets super big. Well, 1 minus 0 is just 1 multiplied by a sub n. That's just a sub n over 1 minus r. So notice this right here is our sum for an infinite series. We just call it the sum is equal to a sub n over 1 minus r. But this right here must be true. The infinite, or the common ratio must be less than 1, or the absolute value of that common ratio must be less than 1 in order for it to sum to something. If it is bigger than 1 or equal to 1, then it will not have a sum, because these terms will keep getting larger and larger and larger, and then we won't find it won't come to a sum. It'll just keep getting larger and larger and larger. So let's try one of these real quick here. Okay, so notice here, this is number 10, one of your homework. Shh, don't tell anybody I'm doing one of your homework problems for you. We're saying the sum of this from k equals to 1 all the way up to infinity. So we're going to add all the terms, infinitely many of them. Well, we're looking at this and we recognize it is a geometric equation or geometric series. where a sub 1 is going to equal to just 11 over 3. And where my r is equal to 3/8. Okay? Well, so since 3/8 is less than 1, or the absolute value of that's less than 1, then we can go ahead and set out trying to find the sum. The sum is going to equal to a sub 1, which is 11 over 3, over 1 minus 3/8. That's just going to be 11 over 3 over, what's it going to be, 5/8. That's the same thing as 11 over 3 times the reciprocal of the denominator, so 8 over 5, which is equal to 88 over 15, which is the same thing as 5 and 13/15. If you want, I'm pretty sure the book's going to have that as your infinite sum. Now for number 14, same thing here. We're going from 1 up to infinity. We'll recognize this is geometric, where a sub 1 is equal to 1/2, and where r is going to equal to the negative 10 over 3. Well, notice that negative 10 over 3, the absolute value of that is actually bigger than 1, which means there is no infinite sum. Alright, now we have one more to work out here. On number 30, they ask us to write this repeating decimal as a fraction. Okay, now there's other methods of doing this, but this is a pretty cool one and a cool way that we can work with an infinite sum. So notice here, 0.090909, this is the same thing as 0.09 plus 0.0009 plus 0.000009 plus etc., etc. Keep that pattern going on, right? This plus all those zeros in that 9 plus all those zeros in that 9, etc. Okay? Well, we recognize that this piece right here is the same thing as 9 times 0.01. This one is the same thing as 9 times 0.0001. This is the same thing as 9 times 0.000001. Right, just a 1 where the 9 was and put the 9 out in front. Plus, etc., etc. Well, this is the same thing as that. And this is 0.01 squared. If you don't believe me, plug it in your calculator. Say 0.01 times 0.01 and you get this, 0.001. And likewise, if you times itself 3 times, you get this number. Well, now this looks really familiar, doesn't it? This is my common ratio. This is my a sub 1. And then this is a geometric series. So this thing right up here, this repeating decimal, is the same thing as, let's say, n equals to 1 up to infinity of 9 times 0.01 to the nth power. So then we can recognize here that a sub 1 is equal to 0.09, and my r is equal to 0.01. So the sum is going to equal to 0.09 over 1 minus 0.01. It's going to be the same thing as 0.09 over 0.99. Multiply top and bottom by 100. That gives me 9 over 99. divide top and bottom by 9 or reduce that. That gives me 1 over 11. 1 over 11. Your homework is down here if you haven't seen that already. It's also up on the board. Good luck, guys.